Alright, so hello and welcome. In this video we are going to build a live cryptocurrency price index using Python, crypto APIs and Streamlit. The code we are building here is extendable for your requirements. For instance, creating indices for whatever coins you're interested in, or you could add some more information here using my previous videos. This index is showing the development for the 10 biggest cryptocurrencies in terms of market cap. Notice that every index has a starting value. In this case, our base value is 1000. If we would press update here, we would get a live update. So the idea again is to build a price index to get a better understanding of the general market development, similar to what we know for stocks, e.g. the S&P 500 or Dow Jones. Just as a side note, both the S&P 500 and Dow Jones are value-weighted indices. We are going to build an equal-weighted index. I'm going more into details in one of the next slides. You need some prerequisites for this video. First of all, you should know how to build a live price data stream and write that to a SQL database using the Binance Unicorn lib. You should understand how returns are calculated, and you should have watched one or two of my prior videos on Streamlit. You should also know how to request data from APIs using the request library. Everything you need will be linked in the video description. As an additional note to avoid misunderstandings, the Binance API doesn't offer a way to get market caps for coins. Therefore, I'm using a Coingecko API call. Let's briefly cover what do I mean with equal-weighted returns or an equal-weighted index with an example. I have two assets forming an index. The first one's return is 50%, the second one's return is 50% as well. The weights of the assets would be 1 divided by the number of assets, so in this case 1 divided by 2, 50%. The equal weight return of the index would simply be 50%, so accounting for the weights, times 50% accounting for the return for the first asset, plus the same for the second asset, as we have the same weight and the same return. So the equal weight return of the index would be 50%. Alright, so let's get started. This script is writing live prices for a bunch of coins into a SQLite database. I've covered this approach in some of my previous videos, so I'm not going that much into detail in this video, but anyhow, let's do a quick walkthrough here. So we need some libraries, pandas for data handling, SQL Alchemy to establish a connection to SQLite, and we need the Unicorn Binance WebSocket API to get a live data stream. This list is containing symbols which are traded both on Binance and on Coingecko. I will link this list in the video description if you want to know how I created that. In a nutshell, I was just comparing the symbols traded on Binance with the symbols traded on Coingecko and was filtering those coins out which are not traded on Binance. Why do I have to exclude them? Because when using a Binance live data stream for coins which are not traded on Binance, I won't get any data. So this is why I'm doing that here. The next step is using a simple list comprehension, adding USDT to those coin names here, right? Reason behind that is if I want to use this Unicorn Binance WebSocket API, I have to provide the coin name plus the coin it should be related to. And as we are interested in the relation to the US dollar, we are using the USDT here to get, for instance, the Bitcoin price to the USDT, ETH price to the USDT, and so on. This is simply using the library and is pulling K-line data on the 1 minute time frame, and we are, as said, providing those symbols which are included here. The SQL import function is just processing the data received from the stream and is writing this data to an SQL database. So you see here we are filtering the received data for only the K-line values, then we are wrapping that into a data frame, and then we are doing a typecast for the close price column to a floating value because we want to do calculations later on, and we only write data to the SQL database when the candle is closed. So we are not taking every data tick, but only those data ticks where we have a closed candle. Here we are giving the table in the database a name. So if we are receiving data for the Bitcoin, which would be BTC USDT, the table name in our SQLite database would be BTC USDT. Finally, we are just setting up an endless loop, which is requesting data from the stream. And these checks I've explained in the previous video. Basically, this is just checking if we have data and if the data is long enough to be an actual data tick. And then we are calling the SQL import function, which is writing this data to the SQL database. So let's start that, and with that we are having a live updated SQLite database. Okay, so let's move on to the next step where we are getting market caps to determine the top 10 market cap coins. Therefore, I'm just opening up a notebook here. Just as a reminder, you have to make sure that this loop keeps running all the time so that you are getting live updates, right? So, getting market caps. We need the requests library and we need pandas. First of all, we need the URL where Coingecko keeps those market caps. And I'm just copy pasting that string, which I have pirated from Stack Overflow. I will credit the author in the video description. So we can just use requests, get, and then provide the URL, get a positive response, and then use the JSON method here. And as you see, we are getting the market cap for the Bitcoin here and for all other coins, right? So here's ETH, getting the market cap and so on. So to keep things simple, we are just wrapping that into a pandas data frame, getting it in a lucid format here. So we have our symbol here, the name of the coin or the ID, and the market cap. All right. Now we have to filter this, so we have 100 rows here, so 100 coins here, right? But we only need those coins which are stored in this symbols list here, right? So these are again the coins which are traded both on Binance and are available in this market cap list. So we have to just copy this list over here and then filter this data frame for only those symbols. All right. So we can do that by simply using df.symbol, accessing the symbol column, and then check is in the symbols list, right? With that, we're getting a Boolean mask here. So to get only those symbols stored in this list here, we need this syntax here. By the way, I forgot to mention that I have excluded stablecoins in this symbols list. So this data frame is not including stablecoins. All right. Now let's find the 10 largest cryptocurrencies. We can just apply the n largest function here, use for the 10 largest values, and check for the market cap column. And then we can just access the symbol column, and then we're getting the top 10 market cap symbols here. So let's just transform that to a list, and we will need that in the next step when we are building the Streamlit dashboard. Okay, so let's move on to building the price index and visualize it in Streamlit. So let's copy paste those top 10 market cap symbols here and open up a new notebook. And before we are starting, so let's quickly wrap that into a variable here, top 10. And before we are starting, I want to quickly show you how I'm doing the index calculation, because I think that's probably the hardest part. But first of all, we need some libraries. So we need Streamlit, of course. Then we need pandas for data handling. Altair is a visualization backend for Streamlit. We will need that to get the right scaled index time series or index line chart. And we need the access to our build database containing the live prices. Okay, so first index calculation. I'm doing that step by step first before I'm wrapping that into a function. So we need an empty list where we are storing all equal weighted returns for those symbols here, right? And as this list is 10 elements long, or in other words, we have 10 currencies here or cryptocurrencies here, an equal weighted return for each currency would be the return divided by 10, right? So we would need to do that for each time step, right? And we know that when we are pulling price data, which I will do in some seconds, we have every minute we have a return, right? So we would need to calculate a return, an equal weighted return for each minute, right? So I'm going to loop for coin in top 10. I'm going to pull data for each coin. So I'm using pd read SQL, provide the coin, and as the table name is BTC USDT, I have to add a USDT here. And as the table name is an uppercase letter, I have to use the upper method to get BTC USDT in uppercase letters. And I have to provide the engine to get the table BTC USDT from this database. All right, so let's execute that. And this will pull data frames for each of those symbols here from our live updated database. So let's take a look at how this is looking like. Of course, now we are only getting the data frame from the very last iteration, which would be AVAX or whatever that is called. Right, so this is how our data is looking like. And this is what I meant, right? We have a price every minute. So every row is a minute, right? And to calculate the return for every row, we can use the PCT change function. So we are applying the PCT change on the close price, which is here, right? So what you could also do is just divide every row with the previous row to get the return, right? But PCT change is doing that for us. So we are calculating the return, red, using the close price, df close price, and then apply the PCT change function. And this would be the return, right? But we need the return divided by 10 because we want to have the return, but only the share of 1/10 of the whole return, right? So we are dividing that by the length of top 10, right? So divided by 10. Now we just need to do one more amendment here. We are just defining an index here, which should be our k-line close time. And we are transforming this Unix formatted timestamp to a human readable timestamp. We can do that by using pd2datetime, provide the k-line close time, and then set the unit to ms. All right, so then we are just transforming this timestamp here. Okay, and once we've done that, we are appending this return series to this return list. So returns append red. All right, so let me show you what we're getting. We are getting lists containing returns series, right? For all those symbols. So this would be BTC USDT. This would be, what was it? ETH, and so on. And now we have the return divided by 10 for all symbols, right? So let's wrap them all together in one data frame. So we could just use pd concat returns and then define the axis as 1. And then we have those lists in a data frame side by side. What you're seeing here, right? So that would be BTC, ETH, what's the BNB, and so on, right? So we have it in a data frame. And now to calculate the equal weighted return of the index, we can just sum up those returns because these are the returns divided by 10. So we can simply sum them up, right? So we need a sum on the axis 1 here. So if I would take sum axis 1, we would get the equal-weighted return of the index. All right? Because I'm taking the return divided by 10 for each of those symbols, and then I'm summing them up. All right? So just apply that on the example I did in the very beginning, and this will be more clear. All right, and as these are the returns over time, we can use the cumulative product to get the cumulative returns. All right, so therefore we would need to add a 1 here. So 1 plus, and then the cumulative product. So I've explained that in other videos. I'm not going much into details. Here I'm just accumulating the returns over time, right? And if I would plot that, I would get the development of my cryptocurrency index. Okay? Now we have this value as a starting value, but we wanted to have a starting value of 1000, right? So we can simply multiply that with 1000, and then we have our index development. Okay, so back to the beginning. Now let's wrap that all in a function so it is more flexible. For instance, you could provide multiple lists, such as top 5, top 10, top 20, or whatever you're interested in, right? So we are creating a function here, redcalc or indexcalc, whatever you like. And this is taking a crypto list containing cryptocurrencies in a list form as an argument. So again, we are defining an empty list here, which we are populating with return data. So we are looping for coin in crypto lists, and then we are pulling data from the database, providing the table name, which is the cryptocurrency name in relation to the USDT in uppercase letters. So just the coin plus USDT using the upper function. And then we are doing the return calculation, accessing the close price column, apply the PCT change function on that, and divide that by the length of the given crypto list to get the share of the return for that particular coin. Then we are renaming the index of this series, not renaming, but we are setting the index to the k-line close time, and we are also transforming the k-line close time to a human readable timestamp using PD2DateTime here. Provide k-line close time and define the unit as ms. Then we are just appending this return series to the returns list. All right, after that we are creating a return frame by using the concat function on the returns, and then we have a data frame containing the returns or the share of the returns on that index, and then we can just take the sum on the axis 1 of those returns, and we have the index return, right? So we are using index series here as a variable name. Take the starting value of the index, which is 1000. You can take whatever value you like, and then use 1 plus redframe sum on axis 1. Take the cumulative product, and we are also giving this series a name, which is index value. And then we're just returning this index series, right? So let's test that on our top 10. And as you see, we're just getting the index development here, right? Could plot that, and we are getting the index development here. Okay, so last but not least, we need to transform this script into a Streamlit readable script, right? So we have to make some amendments. Function stays the same, no worries, but we have to add some more stuff to that. So for example, we want to give it a title, as the title, cryptocurrency indices. Then we want to pull the series out of this function. So we are using redcalc on top 10, and then we have to reset the index to transform the series to a data frame. So Streamlit really isn't compatible with series, right? So without that, it would be a series, but Streamlit doesn't accept series. It's just compatible with only data frames. So we're using this reset index, and then we have a k-line close time column and an index value here, right? And we are storing that in a variable. How can we name that? We're just naming that st object for Streamlit object. And then we want to create an update button so that we are getting the new calculation with updated data. So as we have a live updated database behind that, whenever we are calling this function, we are getting live updated data, right? So we're using if st button update. We want to just do this assignment again. Okay, so don't worry about that. This is what we are doing in some minutes. Now, the next step, I'm not going much into details, but in a nutshell, to create a line chart with Streamlit, you have to use altair. Otherwise, the scales will not be right. So you can try it out with using st line chart, but you will see that you're getting wrong scales. So I have to add a function here, chart creator, but I'm not going much into details here. I will link the documentation so you are understanding this, these next steps. So here I'm just creating an altair chart, and I'm setting the y-axis scales to the minimum and maximum of our index series, right? So first of all, I'm creating a chart here, use alt chart on the provided object here, use markline, encode, define my x-axis as k-line close time, and my y-axis, I'm using alt y, take the index value. And now the fun begins. I'm setting my scale to alt scale, set domain to the object index value. So this is the column containing the index values, and then I'm setting the minimum here as the lower bound of the scale, and the maximum value as the upper bound of the scale. Okay, so in easier words, what am I doing with that? I'm just telling the altair chart that I want the maximum value of my line chart as the upper bound of my scale on the y-axis, and I want the minimum as the lower bound of the scale of the y-axis. Okay, so I also want to set some properties because I want to have a wider chart. So I'm setting the width to 800. Pretty complicated. It took me hours to figure that out because I was trying to visualize that with the line chart. I just showed you that it is working with matplotlib, but for some reason the scale isn't working with Streamlit. So you have to use this syntax here. Okay, and in the end, we're just setting the Streamlit title to top 10 market caps index, and then we are using st altair chart and call the function on our Streamlit object. Right. And finally, we have to transform this to a raw Python file to make it executable with Streamlit. So we can download that. I have to zoom out a bit to download that as a raw Python file. And finally, open up the terminal and type in Streamlit run and pull over the downloaded raw Python file. Execute that. And then a new window is opening up. Pull that over here, where we have our cryptocurrency index, which can be updated by clicking the update button. So yeah, thank you very much for watching. That's already it. So yeah, I hope this was helpful, informative, and feel free to play a bit around with that, extend that, use value-weighted indices or whatever you're interested in. Deploy that somewhere you want. Yeah, thank you very much for watching again, and I'm looking forward to seeing the upcoming videos. Bye bye.